All right, this is the video for Wednesday, the 29th of April, and we're going to continue working with quadratic equations today. Specifically, we're going to be transforming or changing quadratic equations. Yesterday, we introduced three ways in which quadratic equations are transformed or changed, and my goal today is to help you to, number one, identify and understand the three transformations that can take place, and then to be able to look at a quadratic equation and say which of the transformations take place based on what you see in the equation. In other words, without having to solve the equation, without having to make a table for x and y and go through all of the math, basically just to look at it and say, oh, I see what's going on there just because of what's going on around it. So first of all, a few reminders. When we talk about quadratic equations, we're talking about any time where the f of x equals x squared. Now remember, f of x is just a fancy way of saying y equals x squared, okay? But we use f of x because it means all the y's in the world. And sometimes when we're dealing with multiple functions, in other words, multiple graphs, if you will, we'll use other letters other than f of x. It might be g of x or h of x or z of x. It doesn't matter. All of them mean y, okay? So you can write it y equals x squared or f of x equals x squared. They're still the same simple quadratic equation. Now, this is the simplest quadratic equation in the world, and we know it's a quadratic equation because it has an x squared and nothing bigger than that. Let me explain what I mean. If I had a y equals x cubed plus x squared, that's not quadratic anymore because it has an x to an exponent greater than 2. Okay, it becomes something else that we'll deal with in Algebra 2, but not in Algebra 1. In Algebra 1, as long as we have y equals x squared, doesn't matter what else we pack around it. In other words, what else we put over here on this side, it's still a quadratic equation. So this could be y equals x squared plus x plus 3. It's a quadratic equation, all right? So let's talk about those three big ways that quadratic equations are transformed. Now, first of all, let's remind ourselves of what the parent function, or y equals x squared, looks like when we graph it, okay? When we graph y equals x squared, whatever x is doing, if you'll square it or multiply it by itself, then you'll find the value of y. So remember, yesterday we did this thing where we set ourselves up a chart, and then we just started throwing numbers in for x, just picked x numbers out, and I showed you how to do it the simplest way, which is to get the 0 and then the numbers closest to it. If I said 0, positive 1, negative 1, positive 2, negative 2, y is going to be the square of this because y equals x squared. So whatever I chose for x, I'm going to square it, and that's what y is going to equal. So that's an ordered pair. In other words, I'm going to go up here on my graph. This is my y, this is my x. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And I'm going to put a great big dot right there at 0, 0, because when x equals 0, y equals 0. When x equals 1, y equals the square of 1, which happens to be 1 because 1 times 1 is 1. All right, that's a little third grade mathematics coming back at you hard. Here we go. When x equals 1, y equals 1. I'm going to put a big dot there. Well, negative 1 squared, negative 1 times negative 1 is also positive 1. Okay, so when x equals negative 1, y also equals negative 1, and 2 and negative 2 are positive 4. So when x equals 2, y equals 4. When x equals negative 2, y equals 4. And so we end up with this. This is our parabola. Okay, this is the simplest of all of our quadratic equations. Now, I'm going to describe three ways that this parabola can change. based on what I do to my equation. Okay, I can do three things to it. Now, before I get to this, here's what I need to make sure. And I should have made a point of this in all of these videos, but here it is, video number 20, and I'm finally thinking, you know what? I take it for granted that you're smart, but I know you. I can't believe that I didn't point out to you, you need a pencil and paper while you're watching this video, and you need to take notes. Why didn't I tell you to take notes? You took notes, right? You took notes? Promise me you took notes? Because you didn't just watch this like, you know, have this playing while you're doing something else and then say, oh, I watched the video. Don't be dumb. Don't be dumb, okay? Get yourself a pencil. I'm gonna pause it, okay? You don't have to pause the video. I'm gonna pause the video right here. I can do that. And then you're gonna get a pencil and paper right now. And I can count it out in my head how long it takes. So I'm gonna pause this video, okay? You ready? If you don't have a pencil and paper, get a pencil and paper right now. I'm going to pause it. Hold on just a second. Okay, we're back and ready to go. Hope you got your pencil and paper in that amount of time. All right, now, this is our parabola, okay? It is, if I use it as an adjective, anything that's shaped like this is parabolic, okay? But this is a parabola. Now, let's imagine things that I could do to it. I could, number one, I could move it around. Okay, that's what we worked with yesterday to translate it. To translate just means to move, okay? Up, down, side to side. You got that? Up, up, down, down, side to side. Up, down, side to side. That's translation, okay? If I move it up, in other words, if my minimum point, that point where the parabola gets as low as it's going to go on the y-axis, if I move that up here, that's a translation. Move it down here, that's a translation. Move it left, move it right, those are translations, okay? Very simple. If I look at it and it's moved, it's been translated. All right. The other thing is I can dilate it, okay? So when I translate it, let me make some room here. When I translate it, that's called a translation. When I dilate it, that's called a dilation. And a dilation means that it is wider or it is skinnier, okay? So we're just defining right now. I'm going to tell you how to see these in a parabola. So if I took my parabola and I graphed it and all of a sudden it's a lot wider than it was when it was just y equals x squared. Something's happened to it called a dilation. So if you'll notice, my parabola is if it's just y equals x squared, it's very easy to predict where those dots, where those lines are going to touch. And I look at it and think, wow, that's a lot wider than I anticipated. That's a dilation. Also, if I look at a graph of a parabola and it's skinnier than I expected it to be, that's a dilation as well. Okay? I'm going to show you how to find those. You look at that and say, all right, but first we just have to define it. So we know what a translation is. To translate is just to move it around. To dilate means to make it wide or to make it skinny. And then the third is to reflect. We call this a reflection. Okay? A reflection is when the parabola looks like a frowny face instead of a smiley face, okay? Think of it as if you were looking at yourself in a pool of water, right? There's a reflection of you. It's literally reflected across a line, and we have to say it that way because we're going to see these same transformations in all of the graphs that we see in Algebra 2. And so when we start talking about reflections, it's important that we note it's across a line. Right now, Algebra 1, the only reflection we're going to do is just flip it upside down. Later on, we're going to get real tricky and it's going to flip. You know, we can flip it any which direction we need to. But these are the three things we need. Okay, so a little review. If I move it around, that's a what? That's a translation. I translated it. If I made it narrower or wider, what's that? a dilation. And if I flipped it across the line, that's a reflection. All right, now, let's talk about how we see this. Now, last night, in video 19, we talked about moving or translating the parabola. In other words, we saw that if I said x squared plus 3, my parabola would now come down to touch the y-axis at 3, okay? So if I change that to a minus 3, my parabola, that's a real ugly parabola, my parabola comes down and it touches at negative 3. So this one should be, you've got this one locked in, right? If you see an x squared and it's plus or minus, you know that it just moved up or down, okay? Now, you also saw in video 19 that if I take not just the x, but I take something else with the x, in other words, x minus 2 squared, that it moves, this moves my parabola from side to side, okay? So that I can translate my parabola based on, did I square something with my x? Hint, you can't square something with the x if it's not in a parentheses, okay? So if you look up here and you see an x inside a parentheses and the square, you should say it's been translated, it's been moved from side to side. Okay, now the deal is, and this is kind of crazy, but it's just the way that the math works, if this is negative, it actually moves the parabola in a positive direction, okay? Weird, I know, but that's the way that it works. In other words, x minus 2 squared is a regular parabola that touches not at x, not at a negative, but a positive 2. So I take, if this says x minus 2 squared inside, I know it's translated and it goes the opposite direction what the sign is. In other words, if this had been plus 2, then my parabola would have moved to the left or would have moved negatively. It moves opposite to that sign. All right, so a little reminder, it can translate if I have x squared plus a number or minus a number, that translates up or down. If I have an x with another number and both of them are inside a parentheses, it moves from left to right, okay? So those are my translations. Those are my translations. Now, so let's do this. Now that's a little bit of review because we did work on that last night. However, we have not worked on dilations yet. So let's talk about dilations. Again, I'm going to put my trusty old y equals x squared, okay? Now, here's what's going to happen. For a dilation, if I have a number before my x, that's called a coefficient, okay? So if I have a number before my x, it's going to do something to it, okay? So we know that technically I've got a 1 there. So really we're going to talk about greater than or less than. If I've got a, if I have a number that is greater than 1, okay, so 1.1 up to however big your imagination goes, my my parabola gets skinnier, okay? Yeah, let's keep this in mind. If this number, let's say 2x, my new parabola will be skinnier than just y equals x squared. However, if this number is less than 1, such as y equals 1/2 squared, my parabola gets fatter, just the way that it works, okay? So if it's a number that's smaller than 1, it dilates by being larger. If it's a number that's bigger than 1, it dilates by being smaller. Okay, let's look at a number that is both dilated and translated, or an equation is both dilated and translated. Let's say that I had y equals 2x squared plus 3, okay? Now, I'm going to look at this and I'm going to say, this guy right here says dilation, okay? I've got a skinny parabola, and this guy right here says translation. I moved him up 3 points. Instead of touching the x-axis, he's going to come down to y equals 3, okay? So this is what I'm looking for, and this is what I'm going to try to train your eyes to see. Can you figure this out, okay? If you look at this and you say it is a, it's got a coefficient, it's bigger than 1, therefore it's a skinny parabola, it's smaller than 1, it's wider than the regular parabola, and is there something hanging out here? Positive moves it up, negative moves it down from the x-axis, okay? So that's what we're trying to train our eyes to do. We're not having to solve math problems tonight. We're just looking at it and saying, oh yeah, that number attached to the x squared, that's a coefficient, that dilates it. This number hanging out here on the end, that translated or moves it around. Now remember, we've got a third one, and that third one is reflection. And this is very easy. A reflection, let's go, let me clear this out here. This is not going to surprise you at all, okay? I'm going to take everything else off so we deal with just one thing at a time. A reflection is based on, is my coefficient negative? Boom, okay? Is my coefficient negative? So here's my y equals x squared. I'm going to do it in black. And y equals negative x squared. I'm going to do it in red. This, by the way, would be negative f of x equals x squared, okay? So whether I have the negative on one side or the other doesn't matter, okay? The negative function of x squared is its reflection. So this is what I'm looking for. If there's a negative sign right next to the x squared or next to the number that's attached to the x squared, I'm reflected, okay? So if our parent function is this, that's x squared, y equals negative x squared is the exact same function, just flipped over. Okay? So that's a reflection. Now, let's think about it for just a minute. I know that I can see all kinds of things happening to my equation here. So I'm going to try to put it all together, and we're going to look at one massive, wild, crazy, worst case scenario idea of an equation. This guy out here. What if I had y equals, okay, negative 2 times x minus 1 squared plus 3, okay? Worst case scenario, right? What's this guy going to do? Well, I'm not all that worried about you picking up right away on the exact, like where is it exactly, but I want you to look, for tonight's homework, I want you to look at that and say, okay, well, I know that because it's got a number that comes right before x, this is going to be dilated, okay? Because of the negative, it is reflected. Because it's got a number, it is dilated. Because it's got a number inside here, it is translated. And because it's got a number over here, it's translated as well. Okay? So for perspective, this negative turns him upside down. Let's just think about this. The negative turns him upside down. The 2 makes him skinnier, not fatter, skinnier. Okay? The -1 moves him this direction, and the +3 moves him this direction. So that we should have a parabola that when we've fully and completely graphed it, will be skinny, will have moved to the right and moved up. That's everything all in one. This is as hard as it gets, okay? So what are we doing? We're looking for signs. Is it translated? Is it dilated? Is it reflected? Okay? So in your homework assignment, first of all, based on having watched this video, you're just going to define those 3 transformations. Then I've given you some parabolas that are graphed, and all you have to do is say what happened to them. And it can be 1, it can be all 3, 2 or 3 of these transformations, or, hint, hint, it might be tricky, it might be nothing, okay? In other words, you might be looking at it and saying, that's just y equals x squared. So compared to y equals x squared, nothing happened there, okay? And then there's a section where I'm going to give you great big graphs like this. If you've not watched the video and if you're not paying attention to the instructions, you're probably going to try to like solve this and do a ton of work, and I'm going to laugh a lot at your expense, because all you have to do is say, yes, it's translated, it's dilated, it is reflected based on what is in the equation. Anyhow, we're less than a week out, guys. Don't fail math because you're lazy.